I'd like to acknowledge that we are learning today from Will on the traditional territory of the Gidimt'en clan of the Wet'suwet'en Nation. I'd like to also extend a thank you to Wet'suwet'en Community Forest for their support of our seminar series, which included the John Valent fire panel that we had at the Della Herman at the beginning of November. And I'd like to also thank the Bulkley Valley Community Foundation for supporting the center in purchasing equipment so we can do hybrid seminar series of a high quality so that I'm not teeny tiny on a Zoom screen. My name is Dawn. I'm the operations manager at the center, and I also coordinate the seminar series. If you ever have any suggestions or ideas for folks that you'd like to hear from or think would be great contributions to our seminar series, please don't hesitate to get in touch. We are always interested in what people are up to. Thanks so much to Will for joining us today and presenting. He is a Beck expert, I think is probably the easiest way to summarize your really lovely statement about yourself here. He's worked in every biogeoclimatic zone in the province, building classification of both forests and non-timber ecosystems. And in the last 8 years, he's applied this field experience in building machine learning models that project back for climate change adaptation and for predictive high resolution mapping of ecosystems. So thanks very much, Will. Great to have you.
Thanks for coming out. So I'm going to talk about, I was asked to talk about this model that we built, climate change informed species selection, but I'm going to wander away from that somewhat and just talk about sort of reforestation in general. And I'm presenting it as myself, but also Colin Money, who's a colleague of mine at the Future Forest Ecosystem Center in Victoria. We've worked a lot on this together, so I've added him to the list there because we're going to talk about some of the stuff that he's working on in terms of climate change forecasting. And we're both researchers for the government, and I was hired in 1989 by James Pojar doing Beck work, so I've been around for a while. And part of this is like the role of researchers in government, I think.
I'm just going to tweak the view here so that.
And, you know, I kind of view it as like, we're not actually making decisions in government, the researchers, but we're there to provide sort of subject matter expertise, but also to sort of advance thinking about how we manage the resource and build tools to help decision makers maybe change how things are done. So a lot of this that I'm presenting today is, you know, there's no commitment from government to implement it in truth, but it's there for them to perhaps advance kind of what they've been doing with reforestation up till now in history, with the eye that times are changing. So I'm going to talk about sort of climate change, sort of around the Skeena region initially, and then this KISS model about modeling the effects of these climate changes on tree species. And then a bunch of stuff on sort of some real world, like field work that we've been doing to sort of support implementation of this KISS model. So, I mean, everyone knows climate change really has arrived in BC. We had our huge heat dome in 2021, and now, like last year was the warmest on record mean annual temperature. And that's led into, you know, some physical effects like, you know, bigger fire years, but also biological effects, and a lot of the big mountain pine beetle and spruce beetle are sort of symptoms of forests becoming stressed due to climate change. And we're moving out of this sort of historical range of experience. I mean, the climate's always varied, and now as it's sort of getting warmer, we're starting to move into an era where we don't really have the experience in our past management for these things. And so 2021 and then 2023 were sort of above this historic you know, climate. And if we kind of look at sort of looking forward into the future, like 2023, there was essentially a prelude to maybe the best case long-term climate change scenario, like 2.5 degrees warmer than historic. We've already sort of experienced 1.3 in the last 10 years, so we're already warmer. And then if we sort of have current policies, we're like 3 times the change. And if we really let it go, it's going to be a lot warmer. And this is sort of on average, right? The North is warming faster than the global average. So we're really going to be moving out of what we're used to managing for into this sort of new era. So that's, I mean, in terms of climate modeling, the temperatures is pretty much a given. Like that's the physics around global warming with greenhouse gases is pretty solid. But as soon as you get applying that sort of general physics rule into a a global system, it gets very complicated. We're dealing with a complex system, and precipitation is actually sort of maybe the hardest part of that modeling. So temperatures are going up. This is a graph that Colin has built, and there's a tool on the bottom. You can actually go play with some of this stuff, but all of these are global circulation models from a bunch of different international agencies, and we're using those as the projections forward. And there's quite a bit of disagreement among those models. So looking at sort of the subboreal interior, which is kind of us and east, you know, all the models are, you know, they're all saying we're getting warmer, varying degrees, with maybe 3 degrees being by the 2050s, sort of being the average, the ensemble mean. And there's mostly things in this area are not going to get drier, they're just getting warmer. There's a few models that basically say we're consistent, and some say that we're getting wetter. And that 3 degree change in summer mean is about the equivalent of moving our like 4 degrees south. Like 0.7 degrees is sort of an app, like just a very, you know, rule of thumb about temperature change with latitude. So that would put us looking more like you know, the 50.4 degrees latitude. So Kamloops if it's on the dry side, maybe Salmon Arm or Sicamous if we're on the wet side. So we're sort of moving, at least in this area, into like not a phase shift in our, like going to grassland or desert or anything like that. We're just going to a different forest type, is what the model suggests. And if we go farther out and take a more extreme model into like 2100, you know, now, you know, the mean ensemble, there's actually quite a bit more variability in what the models are saying. Like we have some that are like quite a bit wetter, some that are quite a bit drier, some that are 4 degrees, some that are up to 11 degrees warmer. So quite a, you know, as we go farther out, this range of uncertainty gets bigger. But the mean temperature is 8.5 degrees, or sorry, is 6 degrees, which is about 8.5 degrees latitude as a general rule of thumb. And that puts us down on the border of, you know, Washington, Oregon, or central Idaho. Again, forested landscapes. So of any place on the planet, we're living in a pretty good place for climate change. We will remain as forests, but of course, what species would be happy here and how they arrange in the landscape is clearly going to change. So we have this reforestation question, like where then are the right trees in the right place on the ground, given this possible future, right? So climate's a moving target. We can't just sort of make a plan now for some, even a single feature. We have all these features we're planning towards, and we're doing a lot of planting. I think this year we're down a little bit. It's going to be like 260 million trees or something planted, like a huge amount of effort to plant towards replacing the burned over areas, and logged over areas. And so these are pretty big decisions, because essentially we're investing out at least 80 years, you know, like we're investing in trees now, and then they're in the ground until, if we're going to harvest them, you know, sort of 60, 80 years. So there's some long-term implications to this, both financial, of course, but also ecological implications. So, I mean, really, we want to establish, if we're going to be planting, we want to establish, you know, well-adapted forests so that all the ecosystem services that forests provide can be covered. And part of the challenge is that current species selection, you know, is largely based on our understanding of the historic climate responsive species to that. And so we kind of need to, you know, knowing that something's going to change, we need to start looking forward to make species selection based on our understanding of what's going to happen in the future. And part of that is, can we establish them now, as well as will they do well in the future? So in 2021, Colin and I published this paper in Forest Ecology Management, which sort of describes the gruesome details of how this model works. And I'm not going to go into too much detail. If you want the details, I can send you a copy. But really what it's doing is it's tracking trends in species environmental feasibility, like their suitability to site and climate conditions at a site series level. So like a soil moisture nutrient level forward till the end of the modeling horizon, which is 2100s, which is, you know, about 80 years, 75 years now. And we've built this on the BEC system, the Biodynamic Ecosystem Classification System, which is still kind of like as a operational decision-making framework for the government, for foresters. And so we've sort of tied this modeling to the decision-making structure and official term for that is translational ecology, like trying to present information in a way that decision makers can actually digest easily. So, I mean, I think probably most people in this room know what BEC is, this biogeoclimatic ecosystem classification. But in general, it has this sort of climate layer. So we've mapped these bioclimatic subzone variants, and these are essentially ecologically equivalent climates. Like there's repeating patterns of forest community types across the landscape on dry to wet sites. And then within those climate areas, we have site series, we often organize them on an ecotopic grid, which is sort of arranging them on soil moisture nutrient position in the landscape. And those are tied to where they occur on slopes and what the soil conditions are like, et cetera. But the model is this ecotopic grid. And then on each of those site series, there's always been an assignment of a suitability class to species based on those site conditions. So from high to moderate to low are not feasible. And so foresters could look at, if they were in a particular bioclimatic unit on a particular site condition, they could then look at field guides or stocking standards to understand which species would be best suited to that. Otherwise, it would be acceptable, and then a whole list of ones that probably weren't. So we have all that information already in the system, in the classification. And so the KISS tool, basically, we're like, okay, well, let's leverage all that knowledge and push it into a feature perspective is sort of what the tool is doing. And the first step of that is sort of modeling bioclimate redistribution. And this isn't something that we invented. The flying BEC zones, it was called, was published in, I think, 2012 by Andreas Hamann and Tongli Wang out of UBC. And it's basically using machine learning and a climate surface information to then build a model of historic climates and then project them forward. And you sort of get this redistribution of the boundaries of BEC zones around the province. So we've done a similar thing. And machine learning it's a fairly, it's being used for all kinds of things. The large language models are a type of machine learning, but a far more, training data intensive. But random forests is an aptly named, although it has nothing to do with its forestry, a machine learning algorithm that's used quite often. And essentially what you're doing is you're taking training data of known provenance so in our cases, it's spatial points taken from the BEC maps, and then you're attaching climate data to that and historic climate data, which we think of as being like sort of pre-1990, before things really changed. So what the trees were adapted to at that point. And then you take the training data, you attach these spatial predictors, and you put it through a machine learning algorithm, and it kind of digests it down and tries to build a model that would allow it to predict which points based on the climate variables would fit things into each bioclimatic unit bin. So we build a model like that, and then these climate surfaces there's several available now. We use one that Colin has developed called Climber. And in that climate surface, then they project using all those global circulation models through all these features, thinking about different, shared socioeconomic pathways. So like carbon scenarios, essentially. And so you can like have a point in the ground that's whatever, we're in the SBS DK here, and then you attach a future climates to it, and then you can predict what bioclimatic unit it would be if that climate changes. And it's usually for us something that's either more coastal or farther to the south. So we get something like an ensemble change looking at a map. So this is across all the models about in the 2050s. And you sort of see something where the blues are like the subboreal forests, so what we're in now. The greens are like hazelton, so you're into the interior cedar-hemlock, like the rainforest or the coastal rainforest, and the yellow is Douglas fir forest, the red is bunch grass. And so you can kind of sort of see where we are. We're mostly in the blues, and then by the 2050s, this sort of temperate climates are starting to push into the subboreal. The subboreal is being replaced by either wetter climates, ICH, or drier climates, the Douglas fir forests. And so if you look at where our climates are coming from, so I mean, one of the things we did is we built a US BEC model. So we have something from the south to come in. But if you're in the Peace River, it's sort of Alberta climates pushing in is largely what the models say. If you're where we are, it's a combination of the coast coming inland and stuff from the southern interior pushing north. And then if you're in the southern part of the province, you're like Washington, Idaho, sort of pushing into the southern interior, or anything from Northern California on the coast pushing into like the Georgia Basin, so the Victoria area. And then the outer coast is, there's nothing that's as warm, warm and wet in North America. So we sort of have a novel climate, like I'm not sure what it would be equivalent to, like Japan or something, that would be coming into the sort of the hyper maritime. And so, I mean, so we've modeled our bioclimatic redistribution, and then we have to sort of align, these site series together. So we're kind of joining them together through their edaphic position. And so, a site that's like relatively poor and dry in one climate will remain relatively poor and dry. It'll just have a different climate over top of it. And since we have all this management interpretation tied to the site series, we can sort of align the site series and then align what we would do now versus what we would do for species selection in that future climate. And so the model is basically doing, it's doing this hundreds of times in order to sort of generate the trajectory of tree species. And so what you see then spatially is here's like projections for temperate species. So that's like Douglas fir, western larch, western white pine. As the climate warms, the area in the province that's suitable for those species is generally going up. And if you look at the map on the right, the blue is where, we're getting a change in feasibility, like we're adding. And so, something like Douglas fir on average sites, on music zonal sites, is really starting to expand most places and contract in very few places, probably just lower elevations, largely in the southern interior. Boreal species on the other side of that. So the things that we largely plant up here now, pine and spruce, are basically in decline throughout the boreal, sometimes like becoming unsuitable, but a lot of cases just sort of be declining in suitability. So this is a fairly common trend everywhere, is like the temperate species are going up, the boreal species are going down. And in a lot of cases, I don't think I have it in here, but the rainforest species are also expanding because they're temperate, there's temperate and wet. Yeah, so you can kind of see with lodgepole pine here, this is 21 to 24. And as you step through time going farther into the future, it sort of gets worse and worse, the red indicating, declines. So interior spruce, species, sort of the same thing. And so what you sort of see when you sum all this together is that if we just use the species that we're used to planting now, you sort of have like the total number of species that would be suitable to plant sort of is generally in decline. So if you don't do any adaptation, you just say we're going to keep planting pine and spruce. At certain points, some of those species are sort of like becoming unsuitable, and so they probably shouldn't be planted. But if you start adding in all the feasible species, so that's a rearrangement of what you're planting, now you're actually increasing the number of species you would plant. Largely, in that square area, that's the subboreal interior. So that's kind of our area, right? So, those have been sort of mapped views of it. So since we're trying to talk to foresters, we of course have a tool, it's a web tool built in A-Changin that is basically allows foresters to choose their locations on the map and then generate what the model says about those particular sites for specific site series. So in this case, I just picked one that was like the, this eastern side of the subboreal interior, the SBS MC3 is zonal site. And so you would see through time, you have the initial feasibility rating and then model agreement as you go through every 20-year period up to 2100. And so you see, in general, the models are always saying there's a reduced certainty for sure, and usually a reduction for historically feasible species, particularly the boreal ones. And then quite often you have non-local species becoming suitable, and that would need assisted migration because they don't actually occur in that area right now. So, in general, the KISS tool is sort of saying, well, first of all, inconsistent or divergent features is really common. Like you don't have this sort of like we're going from A to B and we know where we need to go. You sort of have this sort of uncertain answer. And often for some sites, there's no like highly suitable. There's only species that are sort of have a lot of uncertainty around whether they're suitable or not, depending which feature actually happens. And so probably we need to do some species diversification to manage that uncertainty. there's with currently suitable species, it's really all over the map, but some remain stable. And site conditions really matter in this case, but some they remain stable, sometimes decline over time, suggested we should reduce their use, and in other cases they're improving over time, which suggests we should start increasing. So that's an easier problem where non-local species may become suitable. Then we're kind of dealing with, okay, well, now we're moving species to where they haven't occurred, so we have to think about what that means, right? And that would be assisted migration. So really what we have is like, historically we used to, say, okay, well, we want to manage that target. We know where we're targeting. Now we're sort of into this condition where, okay, well, those are the targets we're actually throwing for. Like, how do you hit that? And you can't really, like you throw your dart and you managed to hit 2 of the targets, but you haven't really managed all these other quite plausible features. So it's a complicated question, and one that, trying to like communicate that to people who have to make reforestation decisions becomes quite important, because, it's not a straightforward answer sometimes. And so one of the things here is that, we have a tendency to plant single species plantations, and we do the same right thing across the landscape in general. And so if you're choosing the single species, which is often you have certainty, it's like the maximum outcome, is that when you start dealing with uncertainty and like probabilistic losses of single species, which is a common thing for like forest health agents, well, now that becomes a riskier proposition. Like, you could have like the maximum productivity, but you're more likely to have some significant losses with that one species. So your sort of investment has been poor. So if our goal is to, have these feature forests for, all the services we want, ecologists would generally recommend that, okay, first of all, we want to plant species that are adapted to current and future conditions. And we probably want to diversify what we're planting across multiple scales, so forest landscapes, as well as within stands. And I think that's, that would be a generic response from ecologists, like diversity equals stability, kind of. And so, the KISS analysis is sort of giving us, it is giving us that first answer, like, so which species are adapted to now in the future, but it's a complicated answer. And you can kind of see foresters would have a tendency to pick the winner. So like in this example, Douglas fir looks like the winner. Like, okay, it's like a moderately suitable, and it's just becoming better over time. And all the other species are kind of like, well, spruce is kind of going down and pine's going down. It's not becoming unsuitable, but it's becoming less suitable. But then we also have these other species that are, we're now into the 2021 to 2040 period, and supposedly cedar and hemlock are suitable. So should we add some of those? So it's, how would you make a decision what you should plant? So we kind of need then to like build diversity guidance to foresters. If we're going to say, well, you should diversify, what does that mean? It's always what it's going to come back to. So field of economics, investment strategies under uncertainty. Like, so if you know what the feature is, like you're going someplace, you can optimize, and probably you're going to optimize for productivity. If you have a few discrete outcomes, maybe you strategize by probability. If you have a range of features, then you're probably going to diversify, so try to balance risk and return. And then if it's true uncertainty, like you really have no idea, then you're kind of looking for an insurance plan, like something to cover off the fact that it might totally fit. And so, we're probably with KISS and our climate features, we're probably looking at number 3 there, like a range of features to diversify. And the nice thing there is that economists and ecologists agree that diversification is a good thing to stabilize your investment. There's my 3 pictures that generative AI generated for, economists and ecologists shaking hands, agreeing. I really like the central one. That's how I look in the field as an ecologist. They do seem, they profile economists, though. They're all men, and they're all in blue suits with red ties. So here we go. We got Terry Markowitz, who's a good economist nerd. He published a paper in 1952 that eventually got a Nobel Prize in economics, that is basically how all modern investment is the basis of all modern investment. And so it's like optimal allocation of final assets under uncertainty. So you're kind of, that there's going to be perturbations in the market. And so even though you think Apple's a winner forever, you probably don't want to invest in that because it could fail, right? So how do you diversify what you invest in so that you have the, maximum benefit with the minimized down risk. So the mathematics basically do optimize an asset ratios to any, user chosen, client chosen risk return setting that they want. So it's like, well, that sounds good. So why not use it in what we're doing? Because that mathematics would apply across any type of system. So one of the things that we're building is like a modern portfolio version of the KISS output. So it's basically taking all that complicated, potential futures and turning it into a modern portfolio, portfolio, I guess. In this case, is what it's doing is like the maximum return you would have for this particular site would largely be planting almost, 90% Douglas fir with a little bit of larch. That would be like the production forester's choice. But if we're then, moving to the right across this, it's like, okay, well, now we're giving up some maximum return for minimizing risk. And so you get a different blend of species as you go across. That black line is the percent of the maximum possible return. And so, you can go a long ways across that graphic and only give up 10% of like maximum potential. So, then you're saying, well, you could set an arbitrary threshold and say, well, we're willing to give up 10% potential return for less risk of loss. And in that case, that table would show like the 90% return. So instead of planting Douglas fir at 90%, you're now at 40%. You're a little less larch, a little more pine, a little more spruce. So you're sort of providing some guidance on, okay, well, if you really want to diversify, here's some numbers that would be optimally balanced for risk return using mathematics. So this is sort of in the wrong place, but so the key KISS results are essentially that, one of the things is that site matters. So like some of these projections of where suitability is depends on whether you're like on a dry site, an average site, or a wet site. There's definitely risks to just sticking with what we currently do. So doing nothing is actually probably riskier than doing something. And it's, partly the boreal species that we're so fond of planting now are those species that are becoming less suitable. And so we do have some opportunities though for innovation diversification, but that is like, moving species into this region that historically were not here, sometimes by a little bit, sometimes by large geographic distances. And so in order to actually do that, we would need some field trials or some observations at least to help guide that process. So now we're into the fieldwork portion of this talk, which is where, the question is, can these non-local climate change adapted species be successfully established now? And of course, like, should we? So, I mean, I think, you can guess that, but for me, the diversification is a very important part of this. Is like, if we don't do it, then we're sort of reducing them, like we're actually reducing diversity of what we're going to plant. But we need some evidence from the field. So we've been spending the last few years looking at some existing trials of non-local species where they occur. And I think Larry McCullough gave a talk last year, maybe, on some trials that they're doing. And he did work for the research group with Phil LePage probably 15 years ago, maybe even longer, looking at some of these trials. He did a small study. So we continued that work. And then, because there's very few of those research trials, we started planting these operational network of trials for these sort of low risk, low cost trials. So we'll talk a little bit about that. And then also looking at sort of the ecology of one of the tree species, which is probably of most concern to people, which is a deciduous conifer western larch, which has sort of different characteristics than the evergreens that we're used to. So where we're kind of at the, like, BC in general is at the northern limit of a lot of these temperate species. So Douglas fir comes a long ways north, but it doesn't come here. It's basically stops sort of Burns Lake. Western larch, which has been planted throughout this gray zone, and that's been the last 15 years. The chief forester signed off on some minimal planting of larch across that huge area, but the native distribution is really just southeastern BC and down into the US. So we're kind of like where we're at, we're kind of like we're pushing things to the north, but that's of course the way the climate's moving. So kind of makes sense that we'd want to plant those. And really what we're talking about is not sort of assisted migration could be all kinds of things. We're really talking about range expansion because we're not talking about exotics. We're talking about species that are native to Western North America that share a pretty broad latitudinal range, like where they all co-occur. Like the Kootenai mix is maybe the classic, where pretty much all of these things occur with each other in the same stands. But I mean, they do partition off on the coast in different locations, but basically they're all used to playing with each other in that latitudinal range. And so, the question then is, what's the potential for planting some of these species outside of the range in terms of invasiveness? And I would suggest it's probably low. Are there going to be wildlife habitat impacts? Well, in some cases, I could consider it to be potentially positive, unless we did these sort of widespread conversions, like we started planting everything to larch, which seems unlikely. So there has been some planting of exotics in this area, mostly by the feds planted some, but then this is a Northwood trial that's south of Houston, where they planted Western larch pine, so native species, and then like red spruce and Siberian larch, mostly which don't do particularly well. Sometimes Siberian larch does really quite well. It looks very similar to Western larch. You have to look at the cones really to tell them apart. But we're not really talking about implementing those species as climate change species. And so, looking around, it's quite impressive, like how like Western larch is at least 500K outside of its native range, probably farther actually. And it grows very well over quite a wide range of conditions. So these are a couple of stands, like one that's in the SBS DK just south of Houston, Valley Bottom, and then one that's just outside of town here, maybe half hour, and it's like lower ESSF. So larch doing very well. But of course, you choose the wrong place. So I see that they're trying to plant a bunch of it in Chilcotin, and it's too frosty, so bad sites, but we haven't really provided guidance yet on how people should properly move these things. And even, this site that Michelle's standing at with the leaning tree, it was a fail, even though it's very close to the stand on the left, but it was planted in the wrong location. Again, a sort of frost-prone location. So we're trying to figure out, where geographically and climatically they should be planted, but there's lots of considerations around like site selection with some of these species. And here's a ponderosa pine plantation. Again, you wouldn't think it would do particularly well up here, but it actually does quite well. And so there's a stand. This is actually one of the Northwood trial again, south of Houston, where they're growing quite well and they're good survival and producing cones. So sort of the reality of moving species to the north is like, well, it actually largely seems feasible. Most of these stands that we're looking at were planted in the early 90s when there was clearly an interest in planting non-local species. And so we have quite a bit of data. The top graph is sort of just showing, this is more in the interior, but that Douglas fir, FDI, and Western larch LW is about the same site growth as what we normally plant, lodgepole pine. But of course, it's more likely to do better as we sort of move into the future. So as a species, for climate change in mind, it's probably going to perform better than pine and is already doing as well. In Mosquina, where we're sort of moving into the wetter climates, Phil and Larry looked at some stands where, the curves for pine are the red and the green, and then these offsite trials, and some of them were like performing far better than the local species. So, which is an interesting thing to observe, because you're like, well, you have a species that's planted outside of its natural range. Why is it growing, that much better? I think part of that is probably that the Skeena is there's migration lag for trees to get into the Skeena region. And I think for other species too, like rhododendron albiflorum is a super, it's like the subalpine fir forest understory species almost everywhere. And then as soon as you get into the Skeena, it disappears. And it's like, well, why? And I kind of wonder, we sort of there's no upwind source of it, and everything has to seed against the prevailing winds. So, that's, one observation or one theory, perhaps hypothesis of why we haven't seen those species here. And in some cases, like larch, of course, you'd have to also establish through less favorable ground through the frosty Chilcotin Plateau. But something like Douglas fir, it's, it isn't too far west of here. And when you plant it in in the ICH, it really does quite well, all the way up to Bowser Lake, to above like north of Mezia and Junction, it's actually does well and grows really well. So anyway, so we sort of have this evidence now that the Skeena, like the dark green points are sites we visited where it's actually outperforming local species. So it's really doing quite well here. So, I mean, when you look at this though, there's not, it's a pretty sparse number of trials that are up there. And so, you know, in order to understand whether things could be actually established now, we started this called a genesimetric network of offsite species trials. So these are basically operational trials that largely forestry, like BC timber sales and forestry operators are putting in. And they're kind of designed to be these, you know, small, low-cost trials. And the name comes from this paper that I read by Stephen Ziliak, and he used the term genesimetrics because he was going back. They were talking about like this special issue of American Statistician, super exciting. But it was the special issue was about, okay, well, the way we apply statistics, particularly like the p-value in statistics, like useful, or are they taking us down the wrong path? And it was a very thick special issue. So obviously there was a lot of statisticians saying like, let's get rid of this thing. Anyway, this paper was in that special issue. And he turned to William Gossett, who was the brewmaster for the Guinness Brewing Company. And was really the father. He was the person who started modern statistics. And he had a very practical, you know, application for the techniques, which was to improve beer, but using low cost, because you couldn't build big batches of beer and have them fail. You needed to do small batches. And so in this paper, Ziliak kind of outlines these sort of 10, you know, principles for how you use statistics properly for adjusting practice. And when I read that, I was like, well, that sounds exactly what we need to do with forestry. So basically we have these sort of genesimetric reforestation trials, which are these tiny trials. They're only like 25 trees, 5 by 5 trees, widely planted. They're kind of risk-free in the sense that, well, you're not going to fail your free to grow survey. They're not costly to put in. And then we've enlisted operational, you know, reforestation people to be putting these in while they're planting, because they're already out there. It's a trivial task to put these in. And really, you know, if you plant large trials, you kind of don't want them to fail because you've actually invested a whole bunch of money and you're held to account on those. With these things, they fail, which we kind of want them to. We want to be pushing the boundaries, then it doesn't matter. So we've got about 1,600 of those in the last 2 years, so 800 a year, kind of scattered, mostly in the subboreal, like mostly in the north area. We have a few in the Caribou, but you know, lots along Highway 16, all the way north up to Mezia and Junction, and then a few in the Peace, right? And we're kind of dealing with 5 species that are likely candidates for range expansion: Western white pine, ponderosa pine, Western red cedar, Western larch, and Douglas fir. And so we're sort of filling in some big knowledge gaps. So here's Western white pine, like the blue dots are kind of plots where it occurs historically. There's a bunch of, you know, the white plots are places where it was planted, but, you know, out of range, sometimes not very far outside of its range. And then we've basically planted, you know, to the northwest and to the north to sort of actually start creating some information around whether if we plant them, can they even establish as the first call. And same thing with Western red cedar, which has a pretty big distribution, but all the models say it's actually going to be suitable along, as it presses in, you know, along Highway 16, like, you know, west from the Hazeltons, as well as east from the McGregors. So, you know, that's putting in new trials. And of course, I mean, one of the things that has come up not unexpectedly then is, okay, well, if you're moving trees around, are you going to create problems? And so I've already sort of suggested that, well, since these species all play together over a pretty big geographic area, that they're unlikely to be sort of negative competitors in the classic, you know, whatever invasive species sense. But you still have this, you know, if we really did start planting lots of larch, I mean, it does potentially have impact. So I'm not going to say too much about it because we just basically have collected the data on this, and maybe that's another talk for another time. Is, you know, there's these 35-year-old stands of larch around, and so we've got all the data back, not analyzed, for looking at sort of canopy influence on soil chemistry, understory vegetation as well as ectomycorrhizal communities. And so we have that sort of all from the ISACE through to kind of Houston in the SBS, and looking at kind of what the potential impacts of doing a lot of that type of planting would be. And I think, you know, the preliminary analysis sort of shows it's kind of all about light. Like there's not anything specifically different about the tree canopy, but light, the kind of canopy light is the biggest influence on what happens in the understory. So this is a stand of larch in Ekman Pass there towards Fort Babine, and you know, usually you get a lot of litter fall, so the mosses tend to get smothered, but that's, you know, any place where you have like dense canopy cover with lots of needle fall, that'll happen. But with larch, of course, you have lots of needle cast. But then the light regime's better, so you know, black huckleberry is actually doing probably almost best under this stand than the other types. So where will it all lead is the question. So the ministry already is working with a climate-based seed transfer policy that the genetics people have implemented, and that sort of moves seed like populations for climate change. We're sort of in the process of like KISS is kind of working its way to sort of policy approval. I think we're probably like release in the spring is what Colin is moving towards with the FFEC. And then of course we have these new forest landscape planning tables where it's, you know, a venue for setting landscape targets. And so that's the place where I think, you know, some of that stuff, especially around the portfolio analysis, is where we could, you know, start trying to guide instead of all being block specific. We'll start giving, you know, species that we want to see planted across an entire landscape unit. That's the hope anyway. So here's some pictures of offsite trails, Western white pine in the Robson Valley cranking, but that one that we're measuring is actually affected by an introduced rust, which is a problem with that species, but they have rust resistant stock that's about 70% resistant on average. And then one of the genesimetric trials that was put in by Carrier Lumber in the Robson Valley 2 years ago, and it's already, you know, over 1 meter tall. So that larch is happy. And then squirrel food there that Michelle's holding. The squirrels definitely go for Western white pine cones. Like, so like the climate modeling that Colin had there, you know, he is doing it by ecoregion, like Subboreal Interior. I think changing the names of the phytochromatic units, I haven't thought about doing that, because it's also like, well, I mean, part of it's like, what's the starting point? So we're still talking about the starting point. Like when we talk about, you know, okay, well, where are we standing? Well, we're standing in the SBSDK near the ICH MC1. So, I mean, and all the information that we have is currently tied to that.
But I'm wondering, what about broadleaf deciduous species? I didn't see any.
Well, so one of the things, you know, we are modeling that forward. Part of the challenge is there's a little less information in, like, foresters weren't that much interested in them, but in the model, we have them. And so part of changing to a feasibility rating, which is a pure environmental suitability to sites, is to allow, like, you know, back in the day they had to build a stocking standard. Really, all that they're held to now is there's preferred and acceptable species in the stocking standard. And historically, there was a primary, secondary, tertiary rating that was supposed to inform, you know, where people building stocking standards would look at the primary, secondary, tertiary, and then would use that to inform the preferred and acceptable. And that suitability rating was sort of this amalgam of environmental feasibility, reliability, which was forest health, and a set management objective of producing a saw log. And so those were not particularly useful terms or values, partly because the management focus on producing a saw log was such a heavy weighting on that. And so the way that we look at it is like, okay, well, that was the idea of that was a good idea. But what you really need to do is actually separate out the environmental feasibility, forest health, and then apply a management lens. And so the feasibility range is, you know, that'll become sort of standard. And then you can say, well, here's our candidate species, which will include broadleaves at the same rating level, like, is it highly suitable down to low suitable. And then if you're building a stocking standard for wildlife or carbon sequestration or something other than like producing a saw log, you actually have a good starting place to start making that prescription. So yeah, I mean, we're dealing with broadleafers. Yeah, so I had Todd Manning, he was a ministry researcher way back in the day. Who, he has like, it's mostly tree using wildlife. I had him write a report on this subject. And it's interesting, like I also, wildlife researchers like, okay, so, would you take this on? And I mean, I guess the way I sort of look at it is like, okay, well, first of all, what wildlife are you talking about? But also like how much of the landscape is being converted to said new species, particularly larch. That's the one that kind of raises the flag. And so if you look at larch in its native range, it's like, this is a great species for wildlife. And all the species of wildlife we have here are also down in that sort of southern part of the province. So, I mean, I don't think there's any inherent risk, but it's of course like what you do with those species. So the fact that we've converted a huge portion of the landscape to young pine monocultures is clearly a problem. It's not like it's in and of itself the wrong action, but of course you're doing it everywhere, and then it becomes this sort of low diversity landscape of the same thing. And I would say the same thing with some of these new species. You wouldn't want to just say, okay, well now we're doing all Douglas fir and larch. That'd be foolish, and potentially would have some negative like landscape level problems. But something like larch, I kind of wonder like where you see sort of like the where you've been very successful at establishing like a timber producing plantation at a certain age, they get dark, like because they're growing so well, canopies close, and you're walking through them and it's like a nudum understory. It's like almost nothing, right? And so if you add in a deciduous species, it could be aspen or birch or larch, and you started mixing that through the stands, which is sort of what they're doing up here right now. It's all mixed bag planting, and they're just scatter planting larch. In that context, it could actually be like a positive, because now you have these sort of islands of light that are breaking up a canopy that's quite dark. So, I mean, I kind of lean towards it's actually a positive in general than a negative. Certain things like winter habitat like cover. I mean, that is true, but just like down in the Coonies, it's like, well, there's certain landscape positions where you want that, but you don't really need it everywhere, right? You sort of pick and choose your management. So if you're a wildlife manager, you'd be thinking, okay, well, what is our management objective here? Is this mule deer, winter range? And of course, I'm not sure if that really happens up here, but as you go into the caribou and farther south, they've clearly flagged those as being, okay, these areas have a different management objective, and it's winter habitat. So I think that's kind of where that stuff should really kind of get put in place.
We got a question. I'm just going to jump in quick. There's one online here. Can you give any thoughts on using the portfolio theory to start the conversation around landscape targets, given the site-specific suitability of the tool?
Yes. Yeah, absolutely. I think that, I mean, one of the other projects I'm working on is using machine learning to do predictive ecosystem mapping, which is mapping of site series. So the combination of those two would mean that you could actually be probably you could use the portfolio theory along with a spatial map like that to do a pretty good job of at least guiding. I mean, it's at least sort of put some boundaries on diversification, because it really is, if you just say it's like with climate change and species selection, I think Jim Snetzinger was the chief forester, and it was like 2004 or something when he said, okay, we need to start dealing with climate change in all of our management. And it's like, okay, well, that's a good directive, but people have lots of things to think about. It's actually kind of a complicated issue. So you kind of need to, put something in front of people and say, okay, here's this can guide your decision on that. Like, we're not making a decision, but here's some information around what putting bounds around the possible answer. Well, so you mean like a social, like a carbon scenario? Is that what you're meaning, or you meaning?
I just mean that the 76 possible
Yeah.
GCM outputs and.
Yeah.
RCP scenarios and so forth are not equally likely. We're not gonna meet the, the
Yeah.
best case scenario.
Yeah, I mean, largely I've been kind of relying, it was, on David Spittlehouse originally, now it's Colin around kind of what to apply for default settings, let's say. So in the tool, we sort of have default settings, but you can go in and you can say, okay, well, I only want to see, 70. Like I'm just going to turn down the we're going to fix it soon, and we're going to end the average, and I want to show the worst case scenario, whatever. So you can do that in the tool, but as a default, we're kind of trying to be like less picking of winners, shall we say, in that case, and that may change. Like already, some of the global circulation models seem to have a lot of bias, so those are turned well down so that we're not using those. But it is a bit hard to some of these things, it's hard to forecast because it depends whether you're an optimistic person or a pessimistic person. So, trying to accept all of that uncertainty is sort of part of the process. Well, now we'd be into speculation, Ryan, but I think, that's sort of where, things are changing. Like, it used to be, it's okay. Forest Service is setting stocking standards and they're interested in producing the salt log. And that's already started to change quite a bit. And so I think like some of the work that we're doing, like separating out this sort of feasibility rating, actually makes it easier then for people to assign other management objectives, whatever they may be. And so like what will actually happen? Part of this is like we're investing now, and that stuff's going to then be in the ground till 2100 and beyond. And I do think like just sort of assuming certain things, like often like foresters don't want to mix species because it's a bit more complicated, and they're worried about species competing with each other. But some of it's also just the practicalities. Like right now it's easier to sell a stand for harvest that's pure species. What you're getting pine, you're getting spruce. And that idea of like, okay, now we have a mixed bag of species, and maybe larch is too hard, it doesn't go through our mills or whatever is a factor for how they think about it. And you would sort of think, well, yeah, but 80 years from now, are they going to care about that? And probably not, but yeah. So, but some of that value stuff is. Well, so I just want to say, like, I'm not making those decisions. That's a task for, the land managers who are making things. I think the FLPs, like the forest landscape plans, are probably going to say something about what they want to see on the landscape. Like, we don't want to see all timber production. We want to see, other things happen. And so then they would build, assuming stocking standards remain the sort of the guiding force for foresters, for them to meet those objectives. If that's the case, then those FLPs would be making decisions around, okay, well, we want this thing to be, biodiversity, whatever. We want it to be wildlife, but certain types of wildlife, one could say. Fire, suppression, kind of reforestation. Because, we're talking about trees. Climate-based seed transfer is talking about species, but then there's the whole thing, okay, well, how dense are you planting stands? What mixes, there's a whole bunch of other decisions that go into the stocking standards, which have an effect on values, right? So like we're producing one piece of information, probably the first piece of information, which is like, okay, what species are even the candidates for this, especially looking forward to climate change. And then the actual reforestation decisions start tacking on all these other considerations, some of which are generic, some of which are management goals, some of which are site specific, like different sites have peculiarities and those have to be decided. So, there's a long chain of things that actually decide what's going to go on the ground. And some of these, what do we want our forests to be is that's a bigger group conversation, right? And the forest landscape planning is probably where that's most likely to happen at this point. where, you know, communities, First Nations, whatever, have a say in what is happening in terms of reforestation. Whether that's logged ground or fire ground.
Thanks so much, Will.
Welcome.
Great. Thank you, everybody, for attending.